guys, so you're welcome to Webbase. So in this video I'll be talking about Amazon SQS, that's Amazon Simple Queuing Service. So as the name implies, SQS is a queuing service offered to us by AWS. It's highly scalable and highly available. So it basically offers a way to decouple your application. For instance, if you have two different applications that need to communicate with one another by sending messages, SQS is a great choice since it offers a queue for one. So one of the advantages of making use of this is that it's managed by AWS for you, and AWS assures of it's highly available and highly scalable. First, I'll be explaining some terms in the queue. Then we'll be creating a Node application, a Node.js application, where we'll send a message to the queue. We'll also pull the message for the queue, and we can basically see the usefulness of the queue. So let's get to it. So once you sign into the console, your account console, you can simply come to the search bar and put SQS. Then you click on it. So once it's open, you go ahead and you can create on create queue. That's if you've not made use of the service before. So once you're done, so you have two types of queue. You have the standard queue and you have the FIFO queue. That's the first in, first out queue. So they are both similar. So the only thing the FIFO offers in addition is it guarantees the order of messages, right? So once you post a message to the queue, if you select this type of queue, right, it's going to guarantee the order of the message. So we'll be going with the standard since FIFO is a bit difficult to demonstrate. Then we pick a name for the queue, say my node queue configuration. So first thing we see here is visibility timeout. So to explain visibility timeout, we need to understand what happens when you pull for messages, right? So in most messaging service, just like SQS, right, you have the producer and the consumer, right? So the producer is usually just one producing a message into the queue. Then the consumers can be more than one, can be two, three, four, five, as much as you want, right? That wants to pull messages from the queue. So imagine now you have you have an application that processes processes customer orders, right? So imagine a customer makes an order, right? So you want maybe the ID of the order to be placed on the queue so that the consumers or one of the consumers can pick up on it and process the transaction. But you do not want more than one um consumers to process that message, right? So for visibility timers now, when you set it to 30 seconds or 30 minutes or hours, depending on your use case, that you can see from AWS 0 seconds to 12 hours, right? Once you set this, which means when you pull a message, right, the message becomes invisible on the queue for 30 seconds. So in case other consumers pull that queue, they won't see the message, if you get what I mean. So hopefully when we get to building the application, it become clearer. So in summary, it gives the application time to process the message. So let's say it takes 10 seconds to process the message, you can set it to 10 seconds. So we'll see this when we get to building the application. Now for delivery delay, right? Delivery delay now postpones the delivery of new message to the queue. And delivery delay and visibility timeout, they are a bit similar. The difference being that for visibility timeout, right, the message is hidden after it is consumed by a consumer. Whilst delivery delays, once the message is for the first time posted to the queue, it doesn't become immediately available to the consumers. It takes a particular period of time, which from according to AWS should be between 0 and 12 minutes. So now for receive message wait time, right? Now, if you've been in the cloud environment for a while or AWS ecosystem for a while, you would be aware that one of the things to take note of at all times is cost, right? Now, if you look at this page or this page, right, this SQS page, you can see the first 1 million requests to SQS are free. Then after that, you will start being billed for your request. So imagine you have to keep checking the queue every second or every 2 minutes or after every after a particular period of time, right? So that's what this receive message is for. So if you keep a 10 seconds delay, for instance, right, you're simply saying after you poll a message, you wait for 10 seconds to see if any other message will come through. And according to AWS, this should be between 0 and 20 seconds. So basically, it's like a wait time after polling for messages. So you pull for message now and wait for 20 seconds to see if any message will be posted into the queue again. So I think the rest are pretty straightforward. The message retention period is how long the message should be kept on the queue, right? So this should be between a minute and 14 days according to AWS. And then the maximum size of each message is going to be 256 kilobytes. So encryption, this is a bit advanced, but I'll keep it as disabled. Access policy. Now, for assignment, if you've been in the cloud environment for a while, especially AWS, you know you should be aware of permissions, right? So after you have assigned them permissions to your user to access maybe this service, I don't know how the structure of your permissions would look like. You need to also define permissions for your SQS queue, right? Which is a JSON based document also. So you can see it already have some set configurations for us whether we want only the queue owner, being this account that created this queue, should be able to send queue and who can pull message from the queue. So I'm setting this to only the queue owner and only the queue owner for now. So all this I pre-advanced, so I think we are set to create our queue. And we are done. So now AWS gives us an environment where we can test this queue. So we click on send and receive, and then it gives us this environment, right? So say it's asking for a message body, say my first order. Now delivery delay, as we mentioned earlier, this is the amount of time it takes for this message to be available on the queue, right? So because we want it to be delivered pretty instantly, we leave it at 0. Message attributes, which is an optional, we can say order ID, say we can keep this as a number, we can call the number 234, right? I think we are pretty set to send this message. Everything looks good. Come on and click send message, and then the message is ready to be received. So now we simply pull for message. So this pull is a kind of fetching for message, right, from the queue. And if you come here, we should see one available. Let me just refresh the page. So we should have one message that which we have here. So there's a message available on the queue. So now what happens when we click on pull for message, right? What happens is at first, when we click on this polling duration is 10 seconds, set to 10 seconds, right? Which is what we can see here, 10 seconds. So after polling for this message, it means that this environment would wait for 10 seconds to see if another message would come through, right? We can set this to maybe 20 seconds to simulate that, and the maximum amount of message to receive should be between 1 and 999. We can click on save now. So what I will do is click on pull for message, right? And you can see the message if I'm quick enough to send another message. I think it can pretty much go this way. Click on send message. We come down, we see the message being here already, because we are still within the 20 seconds polling duration. You can see the advantage of the polling duration. You wait instead of sending another request to SQS, which will count as another request. It's still now on the same request, but a longer waiting time, which is where we have these two messages. So now, as I mentioned earlier, we have to simulate this in an Node.js environment. Maybe things will become clearer at that point. We'll be able to explain some things there easily. So let's get to it. So now I'm in VS Code, where we can pretty much do what we want. So at first, npm init to initialize this project for Node. Yes. So we have our package already. So we need to install some dependencies. So first we will need the SDK for SQS from AWS. So I think it's AWS SDK / client. By the way, we're making use of the version 3 of AWS SDK. So we hit install. So now the installation is done. I think I can just create say a file. So this will house our AWS credentials file, and then we can have a regular index.js, right? So first things first, I want to set up my credentials, which you can get by going to your console. Your IAM settings, and generate appropriate AWS keys and then secrets, right? I have mine copied somewhere. I'll simply copy it and paste, right? So these are my own configurations. You do well to generate yours. Obviously, I'm going to delete this before making this video available. So I'm simply going to, and also you need to ensure that you have the appropriate permission set. Remember, any explicit deny on this account credential is going to cause failure when we are calling the SDK. So config object set. So now I think we can go to our index full file. So first thing is to bring the things we might need. Require if I can just get spelling correctly. And this is what we'll need. First we will need the SQS client. Yep. And then we then need to bring in our credentials. Right. And then set up our SQS client first. New SQS client, and then our credentials, config objects, what I named it, as this is going to be unique. Then we'll need the Q URL, which we can find right here. So the next thing is I'll simply create a function called create message, or rather send message to queue. It's going to be an async function. You can wrap it in a try catch. Now we create a variable called command. So we're going to need the send command object, send message command. Send message command object, right? Which would take an object in, and we'll have some variables as we defined. So first is the message body, which is going to be the body of the message we want to send. We can have this here. Simply pass it at this point here. Next, we need the Q URL. Simply pass Q URL. Then message attribute. So this is also going to be an object. Say we want to have the first object attribute as order ID, which is also going to be an object. We define the data type, which I think can be string. Yeah. And then we set the I think string value. So 44541 x something of that manner. This is the only attribute I'll be setting, and then finally to send off this command we'll be having we can store the result of the into also an await, and then SQS client send command, and then console log error. Now we can also console log the results to see something out on the console. So finally we call on this function, right? Here's a message to queue and say first message from node, right? And then we can test this out and hope everything works as we want. Node index.js and see if it's going to walk through by sending a message to the queue. Yeah, I think we have a success. We have a response code of 200 and message has been on the queue. So if you followed me along, most likely error you can receive here is maybe permissions error. So you can also confirm your credentials and your region. So, and then we can head back to the browser and see our queue right now, because the message is already on the queue. We can come here, maybe send and receive messages, and then message available 3. I think we had some messages on the queue initially, so we can pull for messages. Let me just delete them, right? And then head back to VS Code and just resend. So we just have one message on the queue. We have a success. Head back to Chrome, then refresh this page entirely. As you can see, we have one message available on the queue. Initially, I was running some tests. That's why we had 3 messages. And if we pull for these messages now, I think we're going to edit this polling duration because we don't have to wait for forever. Set it to maybe 5 seconds. Save. And then pull for messages. We have our message. If we click on it, message from node as we have on VS Code. So I think that's that on sending message to the queue. So now we're going to pull in for messages. How can we pull for messages from the SDK from Node.js? So we create another function, const pull messages, right? Also an async function, and we can do try catch call. So just like what we did for this, we have to get a receive message command from the SDK, right? So const command receive message command, and then we set, since it's an object constructor, some object, right? I think the first thing we're going to be needing is max number of messages. So just like we had when we're doing it in the environment by divided by the maximum number of messages we want to pull from the queue. Say we have 200, how many do we want to pull at a time? We can see 10, just like we had it there. Then we had in queue URL, then wait time seconds. So how long should this call wait for, right, before we get the messages? So we say 5 seconds. We can set it to whatever we want. Then I think there's one I saw in the documentations again, message, I think, if I can just attribute here, I think a comma here, then we can do this await, I think I called it SQS clients dot send command, and then what else? We can log the results, and then also log in case we have an error. Let's see if everything works as we want. Then we can comment you out, call for messages, node index, and yeah, we have our results. You can see some details, but we have the body first message from node. We can simply log results dot messages. Yeah, see what we have. Still waiting. Now we get an undefined, right? If you were quick enough to send this request the second time, you should get an undefined. Now this happened because if we go to our browser, if you come to our browser, right, if you remember when I was talking about the visibility timers, right, I said it's the amount of time after polling, right, that you'd wait that the message will not be available on the queue again. Now remember the idea of the SQS queue. Imagine you have some orders to be processed and you send this message to the queue and it's processed more than once, right? That could lead to chaos. But with this timeout, visibility timeout, right, you set it to take 30 seconds, meaning that once we pull, as we just did, right? Once we get a response the first time, by the time we come again within that 30 seconds window, we won't get a message. So which means other consumers that are going to be calling on this particular queue won't get a message, right? So if I could just simulate it again here, right? We have a message and we run it again immediately. We should get an undefined. Yeah, we got an undefined. So that's that on the explanation of the explanation of the visibility timeout. I hope that's clear. So once again for the visibility time out, right? So basically, I imagine we are doing some processing here. Maybe wouldn't be quick enough in completing the processing, so we can give ourselves more time to process it by the visibility time out. You can also set the visibility time out right here. You can say visibility time out should be 10 seconds or whatever, or 5 seconds also, right? I just leave this as this. So now typically after pulling for messages, the next thing you want to do is to delete the messages from the queue, right? Since you're done processing the order, maybe you've forwarded the acknowledgement mail, you've sent it off to another processing center, right? You don't want the message, this particular message you've pulled for and processed for still to be available on the queue. So the next thing we want to do is to set up a delete message, right, queue. How we can delete the message from the queue automatically once the message is processed completely, once the data is processed completely. So we can do this delete message message from queue, right? It's going to also be an async function and also a try catch. So we can console log error in case, right? And then we simply do this data equals await SQS client dot send. So we also need another command from the SQS package. I think it's called delete message command. Yeah. Yeah, delete message command. So which is going to be this. So I think it accepts an object. So basically it accepts also the queue URL that we set up earlier as a global variable right here. And then it also accepts the receipt handle, right? This is something that's going to be sent to us automatically once we pull for messages, right? So we can, to come clearer, so if I'm correct, yeah. So now after we pull for a message, right, and we get the result, say some processing happens here, some computation, right? The next thing is after the computation is complete, the next thing is to delete the message so it doesn't become available to other consumers, right? But so say we are not able to consume this message or process this message automatically because of the visibility timeout. After the visibility timeout, the message goes back to the queue, right? So for some computation now, after some computation, we want to like delete the results, delete the message. So we say result await delete what they call message from queue, and then we need the receipt handle, and now every message has a receipt handle. If you've observed after the message ID receipt handle, so this is what we pass to the delete queue to be able to delete the message, particular message, for us successfully. So we simply pass in results dot message, and we get our messages packed in an array. So we want to delete the first message, right? I think it's called receipt handle. Yeah, then we can delete successful, right? So after processing this message successfully, then we can then delete it successfully also. Then I think we are pretty good to go for pulling messages. So we can simply node index, then message deleted successfully. So if we come to the browser again and we go back to our queues, we should have the message gone. That's here at this point. We have 0 messages available. So I think we've touched base on the major commands we have for SQS. So the next thing is, in a real life Express application, right, you would want to basically check this queue after particular intervals, right? So you can take advantage of the set timeout intervals, set timeout function rather. So we simply call pull messages for us every, say, 10,000, or say 6, say 9 seconds, right? Pull this out. So first we would need to send some messages before polling, right? So maybe rename this back to first, send the message, send another message, because we've automatically put in the delete handler here, so they just do a second message. Yeah, so in fact we can take it off. They just comment out the deletion, right? So in a real life application, you want to have this run maybe after a particular interval, right? So we do node index, run you, right? So we have 1, 2, set time, oh rather set time, set interval, sorry, we can run it again. We have it first time, then 9 seconds, we have it second time. Okay, so each time we have like a new message in the queue, we have a new message on, you have it updated on this, right? So probably after each computation is done, if you have your deletion back in, after you've processed your results successfully, you can then run deletion again, right? So your message, the queue becomes empty, right? So for Node.js, there's a package that helps us do this faster, right? Imagine we have to write code for pulling the message and for deleting the message automatically, and it's a bit inefficient. So there's a package that's pretty that's open, not developed by AWS, actually by third party, but a pretty good package, right? And name of the package is SQS consumer, right? If I can just, right, so on npm, this is the package, right? You can see it has over 340,000 weekly downloads. So this package helps us do SQS consumption very easily, right? So we can simply just I'll simply touch base on it also to explain how it works. It's pretty simple. So to install it, we simply come on to npm I, copy to clipboard. Now back to VS Code, paste it. So installation is complete. We bring it in. Uh, So as documentation says, we bring in a consumer package here. So if you're used to, I can just maybe comment this out. Express is pretty much the same thing. So we can simply say cons app consumer, right, dot create, right. So it's simply accept an object, right, that takes in the queue URL also. Then for authentication, right, into AWS, you need to pass in your client to it. So SQS, say I think I called you SQS client, right? Then handle message. So this function that we pass here is going to handle the message for us that is received automatically. We have double commas here, pass the message, right? Uh, so basically this package now will automatically delete the message for us once it's handled the message successfully, right? So we can console log message, maybe this message, right? So any message that's pulled is going to be automatically deleted for us by this package. That's the advantage. We don't need to write code. Imagine condensing this whole code into just 3-4 lines. So the next thing we do is since like the way it functions is to call app dot on. So once we have a processing error, we get the error. If you've done error, if you worked with Express, it's pretty much easy syntax. Then maybe we'll call on app.start. All this should make it function as we want, right? But what will happen now is once this is run, our messages will be deleted automatically, right? We can just pull for messages one more time to confirm number of messages we have on the queue. We have 4 messages on the queue, or 5, I believe 5 messages on the queue. So by the time we run this, we should have, when we are done, we'll have 0 after console logging the message. So the next thing is to run node index, right? And so what this package does is to hold the server for us. You'll see what I mean. See, pretty much all messages have been deleted from the queue now. If you go back to the queue, or you come to pull for messages, you can see we have 0 messages on the queue. So, and then if you come here also, you can see at this point we have no messages coming in again, right? In VS Code, I mean, you can see no messages are coming in again. So now back to the browser. I want to send a message, and you will see the message coming in. So we come here, send and receive message, and we see message from AWS console, right? There's no other thing to set, and we click on send message. Now if you come to back to VS Code, I think the message already came in. Message from AWS console, as you can see on our console here. So this package makes this very simple. Once again, thanks for watching. Do subscribe to my channel if you found this video helpful, and you can share amongst your friends. Also give me a like. Thanks. And if you have any further questions to ask, you can leave them in the comment section below. Thanks for watching.